Hello, we will be taking up a session now on real numbers and under which we will be doing fundamental theorem of arithmetic and their application. What is the fundamental theorem of arithmetic reads? Let me just write the topic. Fundamental theorem of arithmetic. What does it say? I'll just read the statement out and then we explain how that is being applied. It says every composite number can be expressed. So if I take any number, suppose a composite number being 65, this can be expressed as a product of prime. So that means if it is a product of prime, that means what are the prime factors of 65? Right? If I'm doing 65 and 5 is it, so it will be 5 into 13. So 5 and 13, they both are prime factors of 65. So this kind of setup, it says, is unique for every composite number except in which the order lies. I mean, I can either write 65 in the terms of 13 into 5. So the order of placing the prime numbers, apart from that, the rest of the whole thing is unique. That means for every composite number, the product of the prime will be unique. That is one theorem. And the second theorem based on this, or kind of a derivation of this, it says if P be any prime number, and A be a positive number, any positive integer, then if, I mean, these are the two assumptions, P being a prime number, A being a positive integer. In that case, if P divides A square, then P will also divide A. Okay, this is one theorem. I will be now taking up a couple of questions on the first one, the fundamental theorem of arithmetic, then we'll learn about the application. The first is, I move on to another screen first. Here I was not being able to fit one question. We will try to find the prime factors of the number 5, 5, 6, 9, 2, 0. Either you draw a factor tree that will give you the prime factors, or you can continue finding it out in the factor format. I will be taking up the factor tree format and will be writing it in the small way, because the first one I'm getting is, this is divisible by 2 and 2 is a prime number, so it is 2. And if I see, I am getting this as 2, 7, then I'm getting it as 8, then it is 2 to the 4, then it is 6, 2, 4, 6, and then there is a 0. So out of this being a prime number, then again we find it out for these two. This is also divisible by 2. This is divisible by 2, and if you divide it, it's giving you 1, 3, 9, 2, 3, 0. Yes. Out of them, again, this is a prime factor. I'll try to continue the same process again 2, and that is, I think, giving me 6, 9, 6, 1, 5, 2. Again, I'm rounding it off to show that these are the prime, or later on I'll do it at one go. Now here I think 5 will be better. 5 divides it. So if I divide it by 5, I might be getting, or it not necessarily that you strike with 5. It if it is divisible by 3, that also is a prime number, so you can carry on with it. But that's because I thought 5 divided by this would divide 5, so I'm getting 23205, because I told you the sequence doesn't matter in which you are writing the prime factors. Again, this is divisible by 5, and that will give me some 4641. This is divisible by not 5, not, this is divisible by 3, yes. So that's what you could have taken 3 there with 6 9 here, or you can take it this at this place, this step. So this, if I divide, it will give me 1547, and this 1547 I think is divisible by 7 as well. So because 7 is also a prime factor number, so if I divide that by 7, I'm getting 221. Now what else will divide 221? This I think is 13 will divide to 221. 13 is also a prime number, so 13, and if I divide, that is giving me 17, and 17 in itself is also a prime number. So herein I have to stop because I got one more number which is also a prime. So these are the, if you express 5 5 6 9 2 0 as a product of prime factors, it will be like 2 into 2 into 2 into 5 into 5 into 3 into 7 into 13 into 17. This is the a representation of 5 5 6 9 2 0. Let us take up an application of fundamental theorem of arithmetic. It says, okay, find the HCF and LCM of these three numbers. I move on to another screen here. I'll just write the question down. It says, find the HCF and LCM of 144, 180 and 192 by prime factorization method. So we have to find it by prime factorization method. Separately we'll do it for 144. We will find the prime factors. We'll find also the factors of 180, and then we find it for 192, and then I'll find the highest common factors. What are the common factors of 144 can be expressed in terms of prime factors, right? So I do it here, some rough work to express. So this is giving me 72, this is 36, this is 18, this is 9, and this is 3. So it is giving me 2 to the power 4 into 3 to the power 2. On the second one, I divide it directly by, okay, I do it by 2, 90, then 2, 45, then 5, 9, and 3, and 3. So it is 2 to the power 2 with another 3 to the power 2 and 5. And 192 similarly can be taken with 2, 9, 18, 1, 6, 2, 48, 24, 12, 6, 3. So it is 2 to the power 6 into 3. So how do you find the highest common of all of them? It is 2 to the power 2 and a 3. That means you will look for the factors which are present in all the 3 numbers, and that is the highest common part. So 2 to the power 2 is common in all 3 of them, and also 1 3 is common in all 3 of them. So it is 2 to the 4, 4 3 is a 12. 12 is the HCF of those 3 numbers. Now come to LCM. How do you find the LCM of these 3 given numbers? HCF, you got it, and the rest of the numbers, like 2 to the power 2 was already taken common, or 2 to the power 2 was already taken common, or you can take out the least of common, like you have 2 to the power 6 here, and what is 3, which is max? This is 3 to the power 2, and there is one more 5. These are the common of all them. This is a lowest common multiple, so you have to find this out. Either you do it this way, the maximum of them you take, or what you do is, once whatever you have taken out as HCF, to find HCF, multiply the rest of them available. Okay, that will also give you the same answer. So if you calculate this, 2 to the power 6 is 64, 3 to the power this is 9, and that's 5, 5 as a 45, and 64 giving me 2880. This is the LCM of the 3 given numbers. Let me just take up one more question on a similar one. Okay, I'll just write it down. It says, find the largest positive integer that will divide 398, 436 and 542, leaving remainders 7, 11 and 15 respectively. I cut it short there. Oh, that is 15, 11 I read, and by mistake I've written it as 1. So it is 15, 11 and 15, 7, 11 and 15 respectively. How do you do it? Is because it is leaving us 7, 11 and 15 respectively. So we have to find the numbers which will be divided exactly by 398 minus 7, because that is the number which will divided by the number which we are going to find. Then it is 436 minus 7, and then 542 minus 7. If we are subtracting, oh, I'm sorry, it is 11 and 15 respectively, not 7, keeping the remainder for all of them. If I subtract with 3, this is giving me 391. If I subtract 11 there, I'm giving 425, and that's 527. Now these are the number which is exactly divisible by the largest possible number which we are going to calculate. As because it is the largest possible integer, we will be calculating the HCF. Not much difference, you just applied. I'm not going to solve this, you can do the rest of them as we did the previous question. Now the answer will be, once you find HCF of all these 3 numbers, express these 3 numbers in as per the prime factors, and then find the maximum the highest common factor of them, and that will be the answer. I hope you get them right. I give you the answer for you to check by yourself. That number will be 17. The HCF of all 3 of them will be 17, but you have to do it by applying the prime factor method only. Hope you get that right. Thank you.